Hello, Mr. Hein is back. And in this video, I'm talking about average velocity and how to calculate given a position graph. Okay. So now, average velocity is the change in displacement over the change in time. That is how we calculate average velocity. And I'm not trying to I say just throw this at you. It's not something to memorize. It's, if you think about it, it makes sense, right? Now displacement, before I go over my example, displacement, make sure you read those math notes to make sure you know the difference of displacement versus distance. For distance is the absolute value of displacement, because you can't use distance because you could have, it's possible to have a negative average velocity if you end up going backwards more than you went forwards. And if you just use distance, you will never get a negative velocity. And that's why we don't talk about the change in distance. We talk about the change in displacement over the change in time. So displacement is the distance from the final destination, not the movie, distance from the final destination to the beginning destination. So it's like the end point minus the start point. And if you think about average velocity, now I'm not trying to give you something to memorize, make sense of this. So average velocity is if I went, say I left my home right today, so my 0, I guess, and in 2 hours, after 2 hours, I arrive 30 miles away. Well, what was my average velocity? Well, I was going 30 miles. I went 30 miles over 2 hours. So I was going 15 miles an hour. Notice that my average velocity was just how far I traveled, but I use the word displacement, not distance here, because again, this is me assuming I'm just driving away in a positive direction, not that I might turn around and go the other direction, because then it'll actually be different. Divide by the number of time it took me. So if I showed you a graph here, and this is not in the work, and it's rather unfortunate it's not in the work, so I hope you're watching this video, because the work assumes you can figure this out from just the problems they give you. But problems like this come up all the time. And we'll say we have a position graph that resembles this curve here. All right, so this is, we'll call this distance in miles. We'll call this time in hours. So notice again that this is a position graph, where each point represents a position we're at. And the average velocity is just the change in your final point, which is right here, minus the beginning point. So it's that change. So if you're looking at like almost like your change in y, right? So the displacement's like your change in y over, and your time, which is your change in x. So average velocity is actually nothing other than slope. But what 2 points do you use for slope is use the end point and the beginning point. So again, it's really just the slope between 2 points. And again, this is average velocity. Make a big note to yourself from a position graph. All right, very different, and you'll see in the next video or tomorrow, I forget when it is, when we look at it from a velocity graph. All right, where this definition holds true, but this idea of slope is only true for this. All right. So it's the slope between 2 points is really all you're finding. So if I wanted to find the average velocity here, this is 0, 0. This is the point 1, 2, 3, 4, 5, 6, 7, comma 2, 3, 4. So your average velocity is just the slope from 0 to 0. And this, we're going to get into, well, yeah, I'm not going to say the word yet. We're just going to focus on this. So your average velocity here is equal to 4 minus 0 over 7 minus 0, which is just equal to 4/7 miles per hour. That was my average velocity according to this graph, right? Your displacement, which is your final point minus your beginning point, where you ended up from relative to where you started, over the amount of time it took you. And that's average velocity from a position graph. But it's important that you understand displacement time. Displacement is distance, but it accounts for negative distances. Distance is just usually with positive numbers only, and we want to account for the negative sometimes. Let me show you an example of what I mean, because I'm sure I'm probably leaving you a little confused. So say, for example, we look at distance, and we'll do it like the slope walk, right? Or hopefully you just did that problem yesterday, so it makes sense to you. And we'll do the time in seconds. So that's 0, 0. And say you traveled, your path followed something like this. Well, notice if this is a position graph, we traveled away from the start, and then at about 2 seconds, we turned around and went back to the start, and then we continued backwards from there. So we actually went backwards for a lot longer, right? We had a negative velocity for longer. So if you think about it, that negative velocity should outweigh the positive velocity. So if you found average velocity here, it would be, what point's that? 1, 2, 3, 4, comma, -2. That's 4, -2. So it'd be -2 minus 0 over 4 minus 0, which notice that you get -2 over 4, which is -1/2. My average velocity was -1/2 feet per second. All right. Over those 4 seconds, I actually traveled more negative than I did positive, and that makes sense. If you use distance only, if you use the change in distance rather than the change in displacement, this graph wouldn't look like this. The graph would actually look like, when it starts to go negative, it actually bounced back up like that. Because you can't have a negative distance. Distance is only positive. So then the average velocity would have actually been +2 over 4, which is +1/2 feet per second. But that's not actually true here because, again, we can account for going beyond the starting point on a position graph. And that's why we don't use distance. Right? That's why we use displacement. Hopefully that makes sense. Right? That was kind of something I just threw in at the end because I wasn't sure if you understood why we use displacement and not distance. All right. So average velocity is positive, which is not true because traveled backwards more than we traveled forwards. And hopefully that makes sense, which implies, a negative velocity should be. Hopefully that makes sense. If not, definitely ask. Not necessarily related to what you'll see other than a fine average velocity. It's your, more or less, your change in y over change in x. Right? But displacement, so final position endpoint minus your start point for displacement. Okay. Good luck on that. Hope that helps you do the assignment.